I'm going to take you through the process of downloading and executing a Phenoflow definition against a particular data source, and in doing so, show off or demonstrate the connector functionality that we have. So in the background, I've got a set of Odyssey tools running from our fork of Broadsea, our KCLH, GitHub, KCLHI/Odyssey. These are our Dockerized version of OMOP, which we maintain. And I've used that to create, to run a set of Odyssey tools locally, including Atlas and a source database with the OMOP CDN as a schema. I've also populated that with some synthetic data, and well, it's the SynPuff dataset. And what I'm going to do for this demo is show how I can execute a definition against that. So I come to the main Phenoflow site, kclhi.org/Phenoflow, browse the list of definitions. I'm just going to pick abdominal aortic aneurysm, AAA, as an example. Here's the definition, and it's here that we see the connector. So the first step of every Phenoflow definition is a connector, and the remaining steps are the logic that actually aim to identify the patients within a given population that have the condition being modeled. And again, the key thing here that differentiates Phenoflow is the fact that typically these definitions will combine into a single atomic action, the actual extraction of data and the identification of individuals with a given condition. So for example, you can imagine an SQL statement actually within a where clause not only kind of interrogates and extracts from the database, but also filters as well, looking, for example, for patients with given conditions. Here we explicitly split that out, so the first step is only about gathering data and perhaps mapping to different codes and then passing it on to the remaining steps for processing. And what that means is, because there's a standard output from the first step, is where that data is obtained from, the rest of the logic steps don't really mind. And that gives us the freedom to then provide different connectors for different data sources that we can switch in and out. So in this case, I know I'm working with OMOP, so I'm going to switch to the OMOP connector. I can hit download here at the top. And what Phenoflow is doing now is it's taking this high-level definition, this structure, which is not directly computable, and it's turning it in real time into a executable version of that definition, which I now downloaded and can actually run against my data source. And in this case, it's a executable CWL workflow. So I can go ahead and extract this, and I can see here my phenotype effectively. So we don't want to worry too much about this, the content here, particularly or especially because we're in the process of abstracting away from this. This is basically just a kind of local representation of the information that we can see on the portal itself. But at this stage, it's still perfectly fine to use. There's a README here that will explain exactly what to do. But basically, I need two dependencies, Docker, which most people are going to have already, and CWL tool, which can easily be installed by pip, for example, the Python package manager. And once I've got those two things, that's really all I need. Apart from that, again, as instructed by the docs, I will obviously need to give some local information about the data source that I have, which in this case is OMOP. So I go ahead and, again, as instructed, find the right variables to fill. In this case, I want to actually know where my OMOP instance is running, so I can fill that information in here. I know I have all that information, so basically an IP address, and then the endpoint, as it were, where the API is located, and then the database source name, which I can grab from Atlas itself. It gives me that identifier there. So once I've added that information in, that's all I need to do. I can now actually go ahead and run this against the data source. So I type in CWL tool. Again, this is all in the docs, and eventually will be abstracted away from. I target the actual workflow itself, which gives all the information, the details about how to run, and then I give some inputs as well, which will be, for example, the different files to execute. And then I can go ahead and run that. What it's going to do now is it's going to step-by-step effectively execute the steps that we've seen here. Again, this is a reflection locally. So first of all, it's going to extract all that data. So we're just using a subset of patients today for the example. It's going to go ahead and run that code that I've just seen. It's going to extract all the patients, and then it's going to analyze them. Now that it's got all the patients, it's going to, as we saw again visually online, it's going to pass them from the collection through each step, and each step will identify, using a subset of codes, whether it has effectively this, a certain subcondition of the condition being examined. So here it is working through, and eventually, once the workflow finishes, we will see which patients, if any, from our population have AAA. Now that the workflow is finished executing, it's going to give us an output file which we can look at now. So we can have a look at the cases file, and it will tell us here, for example, which patients have been flagged as having this condition. So we can see here, for example, patient 1, this is all the data that was extracted, codes and the time of encounter at which those codes were flagged by a clinician. And we can see across the top various sort of subgroupings of codes, so those codes that relate to emergencies, those codes that relate to ruptures, for example, and those codes that are found in different places, e.g. primary and secondary care. This gives us a bit more insight into, just a bit more context about the condition that's being analysed. So we can see for patient 1, we've got a few unclassifieds, but there is a case. So this has identified a case of AAA. And if we look at patient 2 here, we can see there at the bottom, no cases there, no cases for patient 4, no cases for patient 5, and no cases for patient 4, and no cases for patient 5. So we can see here how, in this case, just for a smaller population, we've had one case of AAA. So we've been able to do this from an OMOP database. We could go ahead and download from a different data set now by selecting a different connector on Phenoflow and go through a very, very similar process. Select the connector that we want, download it, fill in some information about our endpoint. And again, because of the standard interface between steps, that will still then go ahead and analyze the data that we have. Of course, this isn't a kind of finite, it isn't a kind of complete set of all the standards that are available. There may indeed be proprietary standards that we'll never model. So one of the things that we provide within Phenoflow is the ability for organizations or institutions to add their own proprietary connectors or private internal connectors for private standards that we might never be able to share and they might not find elsewhere. So the idea here is, for example, that you would download Phenoflow, the source of which is readily available. You would run basically a local copy of this application, and using the API available within that application, you would submit your own connector by providing, for example, a template for that connector. And then what Phenoflow would do is automatically generate, as it has done for OMOP and other standards, it would automatically create your connector, create a computable version of it, and plug it into the various definitions that you want. So our aim is never to kind of perfectly target all standards, but to provide an ecosystem in which different connectors can be developed.